Okay, so let's do some more work now with roots and surds, and let's look at the rule of roots. Okay, the square root of a product is equal to the square root of its factors multiplied by each other. So the square root of the product AB, let's say it was 25, is equal to the square root of 5 by 5, okay? Or the square root of 25 by the square root of 1. So the square root of 16 is equal to, that's the product, is 4 and 4 are two factors of 16, is equal to the square root of 4 fours, which is fair enough, which is the same as the square root of 4 times the square root of 4. But also the square root of 16 is the square root of 16 by 1, which is square root of 16 times 1. Okay? And the square root of a times the square root of a is a. Okay, so if you look here, the square root of 5 times the square root of 5 is 5. Look up here, the square root of 4 is 2, times the square root of 4 is 2. 2 times 2 is 4. That's what we have inside the square root sign. Okay, that's all we're saying here. The square root of 9 times the square root of 9 is the number inside. It's 9. Of 103 by 103 is the number inside, it's 103. Okay. The third rule is the square root of a over b is equal to the square root of a over the square root of b. So look, for example, the square root of 16 over 4 is equal to the square root of 4 is 2. The square root of 64 is equal to the square root of 16 over the square root of 4. Root 16 is 4. 2. 4 over 2 is 2. So let's look at simplifying surds to their simplest form. Okay, there's a method to this, it'll become clear by example, but basically the first step will be to rewrite the surd as a product of two of its factors as roots, like we've kind of learned how to do at the top of the video. Okay, but one of the factors must be a perfect square from this list here, root 1, 4, 9, 16, 25, and so on. And then step 2 will be to evaluate the perfect square part. So if it's root 4, we'll just turn that into a 2. And then, let's bear with me now. And then, I suppose we'll just do it by example and we'll see how it works. Okay, so express root 8 in its simplest form. So our 8 here is our something by something, a by b. Okay, factors, and we want one of these factors to be from the perfect square list. So we'll make always the a factor the perfect square one. Root 4 times root 2 gives us 8, okay, a root 8. So this is the perfect square, so we'll evaluate that, and its square root 4 is 2, and we cannot do that any simpler, it becomes root 2. So root 8 in its simplest form is 2 root 2. What about 2 times root 18? Well, we'll leave the 2 as it is, and we'll turn the root 18 into root 9 by root 2 by its factors. Remember, we're working on the fact that root AB equals root A by root B. That's the rule we're applying, the first rule that we met at the top of the video. So this is the perfect square, it's from that list. So we have our 2 and our 3 and our root 2, 2 3s is 6, and that's 6 root 2. Now remember, it's made of two parts this. It has the rational part, the 6, and the irrational part, the root 2. Okay? Now let's look at adding and subtracting surds. Now we can only add stroke subtract surds if their irrational parts are the same. Adding and subtracting, these must be the same. We'll see later if we're multiplying them, it doesn't matter in dividing, but for adding and subtracting, it must be the same. Okay? And how do we make them the same? We make them the same by simplifying them. Okay? So here's an example here. Simplify root 5 plus the square root of 45 minus the root of 20. So I'm looking for some number that goes into the three of these. Okay, I'm looking to make the irrational parts the same, as all in terms of root 5. Okay, so root 5 plus root 45 is the same as root 5 plus 9 times 5, and of course this is our perfect square. And root 20 in its simpler form is the perfect square, that is root 4 by its root 5. Okay, so now I have root 5 in all three terms, and remember there's a 1 here, you can't see it but it's there. So what I'm going to do now is add the rational part. So 1 plus 3 is 4, minus 2 is 2, and they're all by just the root 5. So the solution to this is 2 root 5. Now, for the multiplication of surds, not the adding and subtracting, the irrational parts don't have to be the same. We'll multiply the rational by the rational and the irrational by the irrational. Okay, so we might have root 6 by root 2, that will give us root 12. Root 12 then is the same as the perfect square, that is root 4 times root 3, 4 3s are 12, and the perfect square ends up as 2 by root 3. So that's multiplying the surd that's root 6 by root 2, that's the same as 2 root 3. Okay, so we've just looked at that one there. So 2 root 3 now by 3 root 5. Well, 2 by 3 is 6, and root 3 by root 5 is root 15. Okay, root 32 by root 48. Well, we can turn that into the perfect square, 16 times 2, and we'll turn this into a perfect square, 16 times 3. So root 16 is 4, root 16 is 4, that's 4 root 2 times 4 root 2 is 4 by 4 is sorry, there should be 3 there. 4 by 4 is 16, and 2 by 3 is 6. Simplify 2 root 5 minus 3 multiplied by 2 root 5 plus 3. 2 root 5 by 2 root 5 plus 2 root 5 by 3 minus 3 by 2 root 5 minus by this minus 9. So then we have 2 by 2 is 4, 5 by 5 is root 25, plus 2 root 5 by 3 minus 2, they cancel out, minus 9. So that's 4 by root 25 is 5 minus 9 is equal to 11. So just be careful, just so you know what's going on here. 2 root 5 by 2 root 5 is the same as 2 by 2 is 4, root 5 by root 5. And we know that root 5 by root 5, root a by root a is a. Okay, it's there. So that's 4 by 5 gives us the 25. Finally, we're going to look at equations involving surds. So solve the equation 2 plus root 4x minus 3 equals x. So we need to isolate this term first of all. So we say 2 plus root 4x minus 3 is x, then this must be equal to x minus 2. Now, we need to get rid of the square root sign, so we square both sides. So this just becomes 4x minus 3, and this has to be squared, which looks like this. And when multiplied together, it looks like that. Then we gather our terms over, and we end up with this quadratic expression, x squared minus 8x plus 7. So then we proceed to find the factors of this quadratic expression. That's x minus 7 and x minus 1. We let x minus 7 equals 0, so x is 7, or x minus 1 equals 0, x is equal to 1. And then we'll sub that value for x back into the original equation, and we'll see, does it equal 7 as per the original? It does, so that's good. And we'll try the x equals 1, and we'll put that in, and we'll see that it doesn't actually equate to the 7 that we're looking for. So this x equals 7 is the answer, not x equals 1.